A data center is a combination of complex hardware in a simplistic environment, and its layout must also be in the same pattern. When looking to increase performance and efficiency within a data center, it is advisable to focus on key factors that greatly affect those two traits, such as power density, power distribution, and temperature distribution. The layout of the data center majorly affects the power density. Certain cooling architectures with a poor layout have proven to decrease the overall permissible power for a given rack by at least 50%. Modern data centers with newer technologies already have power densities that are stressing the capabilities of the data center design, and this is a huge performance compromise in exchange of little to no positive feedback. Power distribution in a data center is supposed to be simplistic, with more complex approaches to this have only proven to make power consumption rise while keeping the distribution low. Instead, the layout for power distribution should be more optimized with the layout of the racks by having longer and straighter rows that will greatly simplify the power and cooling distribution. This will also reduce the overall cost, increase reliability, and decrease unnecessary power consumption. Temperature distribution should be thoroughly planned, because poor planning on this key factor will greatly decrease performance on the racks. A well-known and successful method for the distribution layout is the hot aisle/cold aisle method, which consists of maximizing the separation between exhaust air from the racks with the intake air from surrounding the racks. Establishing cold aisles where the rack intakes are present and establishing hot aisles where the rack exhausts are located will greatly reduce the amount of hot air that finds its way into the intake ports, which improves both reliability and performance of the racks. Making the move from a physical data center to a cloud space is not simply a matter of duplicating your existing physical server resources in a virtualized environment. In a cloud environment, you have much more control over your resources as well as the ability to alter priorities and change your space's operating parameters much more quickly than you could in a physical data center. Purchasing decisions made in